हेलो बच्चों, पिछली क्लास में मैंने पढ़ा था अबाउट द फर्स्ट लॉ ऑफ मोशन। इसका समरी है दैट ऑन योर बॉडी देयर इज मेनी फोर्सेस एक्टिंग, फोर्स ऑफ ग्रेविटेशन, फोर्स ऑफ फ्रिक्शन, electric force. So basically in the last class I told that force F1, F2, F3 and n number of force is equal to what? Total number of force. Today I am telling that on my body, on your body, on the body of the aeroplane, on the body of a satellite, on the body of a planet, on the body of the sun, many forces are acting. So I am not falling down, I am not deviating from the path. So after that we are not feeling direct effect of force. It means sum of all the forces acting on my body, your body, in this board, that is what basically zero. So we are not accelerated. It means acceleration is also what? Zero. Now this is the basically first law. We tell about the quality of the force. I am not talking about the quantity. So if you want to know quantity of the force, come to the second law. In the second law of motion, there is what? Momentum. There is what? Force. This is what? Impulse. So in the second law you are able to explain what is the quantity, what is the number, what is the magnitude, what is the direction of the force. So first we explain about the momentum. Here we are writing about the linear momentum. So a small body, you can say very small body, that is bullet. Bullet is moving with high velocity. So this bullet had very small mass, very small mass. But I keep my hand here. When the bullet strikes with my hand, what happens? Since velocity is very large, so value of linear momentum, value of straight momentum, one dimensional motion momentum is very high. So my hand is not able to capture the bullet, stop the bullet. So my hand is what? Damaged by the bullet. And this is called what? Linear momentum, or simply we can call momentum. Now there is very large truck. So this large truck has what? More mass. Mass is very large. But when it is in the motion, linear motion on the road, so mass is more in comparison to the velocity. There is velocity is less. So if you try to stop this truck, it is also not be stopped. It is now gain the zero velocity by your hands, by your body, by your the capacity. So when mass is more, then also momentum is large, and it is not easy to stop the body having large mass. So you are moving, you are walking, you are in the motion in the park, you are moving in the road or any part of the park, running. So your body has also what? Mass and velocity. So walking person also have momentum. A car is running, car is also has mass, bike is also has mass, scooter and a scooty also has mass, and moving the velocity v, all these getting what? Momentum. So momentum is basically a characteristic of a body. A characteristic of a body. Having mass and velocity. Then it apply force. So force is large in the bullet, force is large in the truck, force is large by your body also, car also. So it is called, that is called momentum or linear momentum, straight line motion momentum. So how can we measure the momentum? How can you measure momentum? So you know practically thus this is what? Mass and velocity both here. So this is momentum is a vector quantity, mass into v. So direction of this momentum is decided by the velocity. If body moves in this direction, momentum also a direction this. If body move upward, momentum is also upward. So velocity decide direction of momentum or p. And what is the magnitude? This is what? You know, this is a vector quantity. Vector quantity. So magnitude is here. mv. Magnitude of momentum p is equal to mass into velocity. So direction is given by the velocity, so that it becomes what? What is unit of this quantity? Mass is kg, velocity is meter per second. What is the dimension? Its dimension is m l t minus 1. This is what? Dimension. So we discuss about the basic thing of the momentum. In the galaxy there is many planets, many stars, including the sun. So one satellite move like this, other is moving like this, third one is moving like this. So momentum of entire planets, entire stars, star is also in the motion. Basically, professor of IIT Kanpur discovered that there is a star, another star moves around that. There is another star, so other star is also moving like that. So all bodies, the earth, your body also, car, rotational bodies, all these have what? Momentum. So momentum of x is here, y is here, z is here, like that. Lekin in the combination, in the concentration, in the growth, entire momentum of the body remains what? Conserved. So you find that what is the magnitude of momentum, what is the direction of momentum, and after that we get that different bodies has different dimension, but in the combination of all the bodies momentum remains what? Conserved, fixed. That is the nature. Keep the system in the conservative form, in the conserved form, not destruction, not loss. So conserve means no loss there, no benefit there. Entire things are acting or combining their nature in the separate form, in the conserved form, in the stored form. So there is no actual change. In the cricket you play, there is a ball, and if ball is thrown by you, so that ball has also got mass and velocity, that is momentum. You are running, also there is a momentum. Fan is running, what is there? Momentum. So momentum or linear momentum has what? Conservation. Conservation in the system, and it also apply what? Apply force. So there is two properties here, and first one is applicable when there is, it is applicable, apply it when there is no any external force is जीरो, है ना। बाहर से कोई फोर्स नहीं काम करेगा तो मोमेंटम कंजर्व रहेगा, है ना। कंजर्वेशन का सिस्टम है। यहाँ तो इसका बेसिक कैरेक्टर है, डिफिनेशन का पार्ट है, दैट इज दिस अप्लाई व्हाट फोर्स। Now second part of the law is what? The force. So I am writing here the rate of change of linear momentum is proportional to force. So if you go to the shop of gold, you can ask what is the rate of the gold. So there is 1 gram gold and price of this gold is also retained. Again, if go to the market to purchase 1 kilogram tomato, you also ask that what is the rate of the tomato. So 1 kg tomato and their price, mass 1 kg divided by their price, 20 rupees, 30 rupees, 40 rupees, 80 rupees. When price of tomato grow in the market, it was 200 also, 150 also. So in the general, your life, in the general conditions, mass is divided by the money. In this case, in the physics, in the science, there is rate is what? That quantity divided by time. So quantity is in the numerator and time is denominator. So this force is what? F is here proportional to rate of change of momentum in the form of differentiation, and when the proportional goes, there is what? A constant, and dp is what? dp has value mass into velocity upon dt. You know, in general condition, mass is what? Constant. There is no change in mass. So you can write here k into m, now dp upon dt. So the mass we considered what? constant of the body. Therefore, you know dv upon dt is what? This is what? Acceleration. So I am writing here F is equal to K mass into acceleration. Then suppose there is acceleration is 1 meter per second square. Mass is also here 1 kg and force is also here 1 Newton. You know from the 9th or 10th, unit of the force is what? Newton. Now this is basically 1 unit. 1 unit. This is also 1 unit. This is also 1 unit. What will happen? Mass is 1, acceleration is 1, force is 1. Therefore, what happens here? Value of k also becomes what? 1. So when there is new quantity in physics, any quantity in the physics, any formula in the physics, entire formula is made of 1 unit. So since mass is 1, acceleration is 1, force is 1, the k will also what? 1. Now in this case you can write the formula of the force final. Since value of k is what? 1. Therefore force is equal to mass into acceleration. So here direction of the force decided by, directed by acceleration, directed by acceleration. So what is the direction of acceleration? Same will be the direction of the force. There is no change in direction of the force if there is what? Acceleration. Again, what is the magnitude? So F is equal to m into a is what? Magnitude. You know force is a vector quantity. Now this unit is what? Kilogram meter per second square. Its dimension is ml t minus 2. A unit you know, force and unit what? This is also called Newton. When a unit acceleration and unit mass exists in a body or particle also, then it has 1 Newton force. 1 Newton force. It means I told you in the entire physics, entire formula is based on what? 1 unit. Every calculation is based on what? 1 minute. Or the data given. We can change the unit if there is 10 Newton force. If there is 10 meter per second acceleration, 10 meter per second square acceleration, then your data can change, calculation can change basically. Thank you very much. In the next class, we study about the impulse. So what is impulse? In the very small time, there is a reaction, there is activity, that is called what? Impulse. आप किसी को थप्पड़ मारते हो तो कम समय में आप थप्पड़ मार रहे हैं, that is what? Impulse. You use force to on the keel